Welcome to the lecture on power plants. Now, let us move to diesel power plant, DG, right? Utilizes diesel engine to generate power. Generally, they operate between a range of 2 to 5 megawatt power generation capacity. They are used as central stations for small and medium power stations. They can be used as standalone power plants to hydroelectric power plants and steam power plants for emergency services. When the power failure happens, we always put a DG. DG is we put a small setup which is called as a engine, but when it is large, it becomes a power plant. They can be used as a peak load plant in combination with thermal and hydroelectric plant. Majority of the time what happens during the evening hours, all of them use AC. So, now the peak power goes higher. The peak power, when it goes higher, normally what happens, the power which gets supplied from the grid, they undergo a instability. In order to make the power supply stable, these DGs are used as a peak power or peak load point controller. They are quite suitable for mobile power generation. For example, you can move from place to place and place. So, if you see all the cinematography industry, they use a generator which is portable. So, the mobile power plant generation and widely used in transportation system such as automobile, railways, aeroplanes and ships. Mobile towers are today also attached to the mobile power generation unit. During Kumbh Mela, at several points they had this mobile power generation and mobile towers, so that so many people could use it and access. So, there diesel is used. Again, the power generation is very low, 2 to 50 megawatt, and when you talk about mobile towers, it will not be even so much. Nowadays, power cut has become a regular feature for industry. The only solution to tie over this difficulty is to install a DG. This is a typical diesel power plant looks like. So, you have a fuel which is stored. So, the fuel is filtered and then it is pumped. It is taken to a day tank. From a day tank, it is again taken to a fuel injector pump, and from there it starts burning and then it starts generating heat. Okay. So, this day tank, it goes here. Then you also have a starting air tank. So, the air compressor is there. So, it gives you the air. So, this air is also sent to the filter. So, this is a diesel engine. So, it is sent here. So, the tank, the fuel comes here, it is getting injected by a fuel injector. So, then there is a piston movement. So, this piston movement tries to rotate the engine. This engine is attached to a generator and then you take an output. So, since there are moving parts, there is a need for lubricating oil tank. So, that takes care of the friction part whichever is involved. So, you will have a lubricating oil tank. So, that lubricating oil tank gets the oil from an oil pump. Then we have a oil cooler. So, this is also used, that comes from the heat exchange. So, cooling tower is there. Then you have raw water pump is there. So, this is how it keeps generating. The jacket of water is getting pumped and it is coming here. You have a silencer on the top through which the exhaust goes up. So, this is a typical setup. You will have a tank, you have a compressor, this is the engine, this is the lubrication and cooling tower if there is requirement. Diesel engine or combustion ignition engines, as they are called, are generally classified as 2-stroke or 4-stroke engine. The diesel engine, air admitted into the cylinder is compressed to a ratio somewhere between 12 to 20. At the end of the compression stroke, the fuel is injected, it burns and the burning gases expand to do work on the piston. The engine is directly coupled to a generator and the gas is exhausted through from the cylinder to the atmosphere. This is what is the silencer said, through which the air gets exhausted. Engine starting system, this induces air compressor and a starting air tank. The function of this system is to start the engine from the cold or by supplying compressed air. So, this part. Then the fuel system. The pump draws diesel from the tank and supplies it to a small day tank through the filter. Small day. So, you had large tank, you try to send it to a smaller tank and then here. So, the pump draws diesel from the storage tank and supplies it to a small day tank. From the day tank, it is then sent to the filter. The day tank supplies the daily fuel need for the engine, because you might have a larger tank, right, and then smaller tank. The day tank is usually placed high so that the diesel flows to the engine under gravity. The diesel is again filtered before injecting into the engine by the fuel injector pump. So, what happens is you will have a fluid. This fluid will be pumped to increase the pressure. So, that to increase the pressure, that is done by the fuel injector pump, right. So, larger tank, smaller tank, then you have an engine on one side. So, there has to be pressurized diesel which is to be injected. So, you will have a fuel injection pump. The fuel is supplied to the engine according to the load of the plant. The air intake system, because here it is mixture of air and diesel. So, air intake system, the air filter is used to remove the dust and the other unwanted particles. The air filter is dry, so that where it is made of felt, wool and cloth. So, it is dry. So, you can remove the filter and clean it also. Exhaust system, in the exhaust system, the silencer muffler is provided to reduce the noise. Engine cooling system, the temperature of the burning gas in the engine cylinder is of the order of 1500 to 2000 degrees Celsius. To keep the temperature at a reasonable level, the water is circulated inside the engine in the water jacket, which are passed around the cylinder, piston, combustion chamber, etc. The hot water leaves the jacket, is sent to the heat exchanger. You can reuse the water. So, because you have an engine, so now there is water which goes around. So, the water will try to remove, water is a working fluid, it will try to remove the heat and come out. So, now whatever comes out is still very hot. So, then that will be passed to a heat exchanger, where it is exposed to cold air and the temperature comes down, so that it is a closed loop system. Raw water is made to flow through the heat exchanger, where it takes up the heat of the jacketed water. It is then cooled in the cooling tower and recirculated. If you see here, there is a cooling tower also, right. Engine lubrication, as there are a lot of moving parts, there will be friction. The friction has to be reduced. So, the lubrication has to happen. The lubrication, whatever you do, can happen at by gravity, or it can go through its small force, but it is good to have a lubricating pump, so that the lubrication also will move back and forth in a pressurized manner. It includes lubricating tank oil, lube oil pump and a cooler. The lubrication is, and why a cooler? Because the lubrication which tries to lubricate, the temperature, working temperature there is 1500 to 2000 degrees Celsius. So, the lubrication also becomes very hot. So, that has to be cooled. The lubrication is essential to reduce the friction and wear of the engine parts, such as cylinder wall and piston. The lubricating oil will get heated due to friction, and moving parts is cooled before recirculation. The cooling water used in the engine is used for cooling the lubricant also. So, you can see here, here is a fan which is almost like a radiator, a fan is there. So, then you see the airflow which is happening. So, here the lubricant is flowing. So, you see the lubricant from here, it flows and then it moves through the cold air, and then it comes and then it goes down, and then here it starts taking heat. So, the advantage of diesel pump, it is easy to set up, it is quick start. Thermal power plant, nuclear power plant, hydro power plant, if it is switched off to start, it takes a long time. And hydro, if the water is drained, it cannot. So, that is a big problem. So, the most easiest to establish, the quick to start and can be built anywhere, easy to operate and very good efficiency is diesel. But the only thing is, it cannot go for very heavy power. What is the disadvantage? The cost and the limited power. Cost is because diesel, if you want to run a diesel generator, it consumes huge liters of diesel, right. So, that is expensive. Then it is also, because there are a lot of moving parts here and there, maintenance is also regularly needed. the next one is gas turbine power plant. In gas turbine power plant, we try to use the gas. So, here the air is filtered and passed through a LPC, low pressure compressor, then it is a high pressure compressor, then it is a high power turbine, then it is a low power turbine, then you have a load, right. So, here the air filter tries to send air to low pressure compressor, it is compressed to a higher pressure, and then that in turn is pushed into a turbine. So, the work is done. Then once the work is done, so there is a loss of the reduction. So, that goes to the low pressure turbine. There also we operate and the turbine rotates, the load is taken. So, from here what we do is we try to have, this is a low compressor, high compressor. So, this is intercooled by a cooler, by a fluid. Then we have this connect of CC which comes from the high pressure turbine and the low pressure turbine, they get connected and there is a CC, and that is sent to the regenerator. Okay. These are gas turbines which are used in, as I told you, in planes. The LP air compressor, in a LP low pressure air compressor, the atmospheric air is filtered and compressed in stages. First in low pressure compressor powered by a turbine and then further compressed by a high pressure stage with an intercooler between them to reduce the power consumption and the improved efficiency. Single stage compression is going to be very costly. Second thing, it is going to increase the temperature and pressures phenomenally high. So, it has to be cooled. So, that is why we try to send this low pressure compressed power by the turbine and then further compressed air in a high pressure stage with an intercooler between them to reduce the power consumption, right, and improve the efficiency. What is an intercooler? An intercooler is used between compressing stage to lower the air temperature, reduce the work required for compression and increase the overall efficiency, as the compression energy is proportional to the inlet air temperature. So, intercooler is in between two compressor, low pressure and high pressure, between the compression stage to lower the air temperature, reduce the work required for compression and increase the overall efficiency. That is what is done by the intercool. Reduce the temperature, air temperature. The HP in the high pressure compressor, the air from the intercooler is further compressed to a higher pressure and then sent to the regenerator as a heat exchanger for heat exchange. Regenerator is used to save energy by capturing heat from the hot turbine exhaust and reduce it to preheat the air going into the combustion chamber, which reduces the fuel consumption. So, you see here combustion chamber, CC is nothing but combustion chamber. The regenerator is used to save energy by capturing heat from the hot turbine. Where is a hot turbine? There is a hot turbine, high pressure turbine. From the hot turbine exhaust and using it to preheat the air going into the combustion chamber with a reduced fuel consumption. CC or combustion chamber. In the combustion chamber, the hot air from the regenerator mixes with the injected fuel and burns, producing high pressure, high temperature gases that is used to run the turbine blade. So, now you can see here. So, from the low pressure, it is combustion chamber, it is sent to high pressure, right, turbine. Whatever comes out of high pressure turbine is done here and it is sent to a regenerator. Regenerator removes the heat and sends it to the high pressure compressor. Captures heat from the hot turbine exhaust and using it to preheat the air going into the combustion chamber with reduced fuel consumption. So, the CC, what it does is produces high temperature, high pressure gas that is sent to the turbine for the power generation. The gas turbine hot gas from combustion are expanded through high and low pressure turbines. Some of the energy runs the compressor while the rest, about 34%, is used to produce the electricity. This is how a gas turbine plant looks like. What are the advantages? It is compact and lightweight, slightly bigger than the diesel. Gas turbine plants are smaller and lighter than steam power plants of the same capacity. Quick start, it is possible. They can start quickly and reach full load very faster. Lower initial cost as compared to the thermal power plant. What are the disadvantages? Low net output. A large portion of the turbine power is used to run the compressor, reducing the net output to run the compressor. So, where are the compressor? The compressor, the low pressure compressor and high pressure compressor. They take 66% of the energy, right? The high material required, it needs special high temperature metals due to very high operating temperatures and speeds. So, now we will try to see what is the comparison between nuclear and steam power plant. The cost of electricity generation is nearly equal in both these plants. The advantage and disadvantages are as follows. The number of workmen required to operate a nuclear power plant is much lesser than the steam power plant. The capital cost for the nuclear power plant falls sharply if the size of the power plant increases, because the major cost goes in structural material, piping, storage, etc., etc. The cost of the power generation by nuclear power plant becomes competitive with cost of steam power plant above the unit size of 500 megawatts. So, if you try to put the size with respect to cost, or if you put size with respect to cost, so maybe it will go like this. So, this also will come like this, something like that, right? The boiler, we have seen there are two types of boilers. One is called as water tube boiler, the other one is called as fire tube boiler. The water tube boiler, the water is circulated through the tube and the hot products of combustion flow over these tubes. In fire tube boiler, the hot product of the combustion passes through the tube, which are surrounded by water. So, the fire tube boilers have low initial costs and are more compact, fire tube boiler, where you use gas to flow through. But they are more likely to explode. Water volume is larger and due to poor circulation, they cannot meet quickly the change in steam demands. That is the problem with the fire. Initial cost is low, but it can explode. For the same output, the outer shell of the fire tube boiler is much larger than the shell of the water tube boiler. Water versus fire tube boiler. The merit of water tube boilers over the fire tube boilers, the generation of steam is much quicker due to the small ratio of water content to steam. This will help in reaching the steaming temperature in short time. So, this is water temperature. Its evaporative capacity and steam pressure range is higher. The heating surface are more efficient as the hot gases travel at right angle to the direction of water flow. The combustion efficiency is higher because the complete combustion of fuel is possible as the combustion space is much larger. What? The thermal stresses in the boiler parts are less as different parts of the boiler remain uniform temperature due to quick water circulation, that is for the water tube boiler. Finally, the damage due to bursting of water tube is less serious. Therefore, the water tube boilers are more safer than the fire tube boilers. So, evaporative capacity and the steam pressure range is high up to 200 bars. So, the demerits, it is less suitable for impure and sedimentary water. They require careful attention. The maintenance costs are higher. The failure in feed water boiler, even for a short period, is liable to make the boiler overheat. What are the requirements for a good boiler? Because everything goes around a boiler here. The boiler should have the capacity to generate heat at required pressure and quantity as quick as possible. This is very important. The initial cost should be low, installation cost should be low. The boiler should be light in weight and occupy lower floor space. The boiler should be able to meet the fluctuation demand without pressure fluctuation. When the water content increases, decreases, fluctuation, demand without the power fluctuation. All parts of the boiler should be easily approachable and repairable. The boiler should have minimum joints to avoid leaks. The boiler should be erected at site within a reasonable time. So, installation cost very low. The time of installation also should be very low for a boiler. Steam condenser. A steam condenser is a heat exchanger that converts low pressure exhaust steam from a turbine back into liquid form by removing heat. So, condenser, there is a phase change happening, is a heat exchanger that converts low pressure exhaust steam from the turbine back into a liquid form by removing heat. This process is crucial for maintaining efficiency of the turbine operation. This is very important. There are two types of condensers. One is called as jet condenser, the other one is called as surface condenser. Jet condenser are also called as mixing type. In jet condenser, the cooling water directly mixes with the steam. The steam comes from here. The cooling water directly mixes into the steam. In surface condenser, the surface condenser keeps the cooling water and steam separate, with heat transfer occurring through tubes. So, there are two types of condenser: jet, where water and the steam is mixed, cool water. The next one, surface, is you try to have two independent, there is a heat transfer which happens such that it gets cooled. The principle is the steam enters the condenser and comes in contact with tubes carrying the cold water. As there is a heat transfer from the steam to the cold water, the steam condenser condenses into liquid water. The condensate is collected and pumped back into the boiler for reuse. Meanwhile, the air extraction pump creates a vacuum inside the condenser, lowering the pressure below the atmospheric level, which helps improve the turbine efficiency by increasing the pressure drop across the turbine and facilitating easy circulation of cooling water and condensate flow. So, this point is very important. This is how a steam condenser works. What are the advantage of a surface condenser over a steam? Surface is what is we are very important. What is the advantage and disadvantage of surface condenser? The condenser can be used at boiler feed water. The cooling water of even poor quality can be used. High vacuum can be obtained in the surface condenser, which increases the thermal efficiency. Disadvantages: it is costly, maintenance, and it is bulky. To recap what we have seen in this lecture, we have seen what is a power plant, what are the different types of power plant, then different components of a thermal power plant, DG, gas turbine. We have also seen what type of boilers used for steam generation, then the requirements of a good boiler, and finally, we saw the working principle of nuclear power plant. These are the references used, and thank you very much.